One of the most important concepts in chemistry that every student must understand is the idea of the conservation of mass, which states that in any chemical reaction, the total mass remains constant throughout the entire process. This means that mass is never lost or gained, and no atoms are created or destroyed during a chemical change. The only thing that actually happens is that the bonds between the atoms are rearranged, forming new substances with different properties. To illustrate this, let us consider a simple reaction where sodium reacts with chlorine to form sodium chloride. Since each molecule of chlorine contains two chlorine atoms, we need to make sure that we end up with two molecules of sodium chloride, which in turn means we must begin with two sodium atoms to keep the number of atoms balanced. This requirement to have equal numbers of atoms on both sides of a chemical equation is exactly why we balance chemical equations in the first place. We can also verify that mass is conserved by checking the total relative formula masses of the substances involved on each side of the reaction. On the left side of the reaction, we have two atoms of sodium, each with a relative atomic mass of 23, giving us a total of 46, and two atoms of chlorine, each with a relative atomic mass of 35.5, giving a total of 71. When we add those together, we get 117. On the right side of the equation, we have two molecules of sodium chloride, each consisting of one atom of sodium and one atom of chlorine, which gives us 2 times 23 plus 35.5, which also equals 117. So, we can clearly see that the mass is balanced and conserved. Another way to think about this principle is to look at actual physical masses involved in a real-life experiment. Suppose we reacted 2.3 grams of sodium with 3.5 grams of chlorine gas. Provided the reaction goes to completion with no leftover reactants, the total mass of the resulting sodium chloride should be the sum of the masses of the reactants, which is 2.3 plus 3.5, equaling 5.8 grams. Therefore, if this experiment was carried out on a set of scales, the total mass would remain unchanged before and after the reaction. However, there is an important exception to this rule, especially when the reaction involves gases. The mass might appear to increase or decrease, but this is often just a result of not accounting for all the reactants or products due to the presence of a gas that either enters from or escapes into the air. For instance, when heating a metal like magnesium in the presence of air, it reacts with oxygen to form magnesium oxide. Because the relative formula mass of magnesium oxide is greater than that of pure magnesium, the final product appears to weigh more. For example, 1 gram of magnesium may react to produce approximately 1.6 grams of magnesium oxide. If the oxygen used in the reaction came from the air around the reaction setup, it would seem as if extra mass appeared out of nowhere. But in reality, our weighing scale just failed to include the mass of the gaseous oxygen in the initial measurement. This is why, to accurately measure the masses involved in such reactions, we need to ensure that the experiment is performed in a sealed container. In such a setup, the gas is trapped along with the other reactants, and when we measure the mass of the system, we are measuring the mass of everything involved, both the solid magnesium and the gaseous oxygen, so the principle of conservation of mass holds perfectly. On the other hand, let us consider the decomposition of calcium carbonate into calcium oxide and carbon dioxide gas. In this reaction, the gaseous carbon dioxide escapes into the air, resulting in a decrease in the measured mass of the products compared to the original mass of the reactants. This apparent loss of mass happens because the escaping gas is no longer part of what the scales are measuring. But just like before, if we were to conduct this decomposition reaction inside a sealed container that prevents the gas from escaping, the mass of the system would remain the same before and after the reaction, thus confirming that mass has indeed been conserved. To quickly summarize the key points from this explanation, the first and foremost principle to understand is that of the conservation of mass, which states that the total mass remains constant in a chemical reaction. This applies whether we are measuring in grams or simply counting the number of atoms involved. If the mass seems to increase during a reaction, it is most likely because one of the reactants, such as oxygen, was a gas that entered the reaction from the surrounding air. Conversely, if the mass appears to decrease, then it is probably because one of the products was a gas, such as carbon dioxide, which floated away and was not measured. To prevent these apparent changes in mass and to maintain accurate measurements, we must always conduct such experiments in a sealed container that traps all gases and ensures every atom is accounted for. That wraps up everything we needed to discuss in this video. We hope this helped clarify the principle of mass conservation for you, and we will see you again next time.